All right, this video is going to be an explanation on how to do word problems with regards to rate, time, and distance. Here's a particular problem that students are going to be struggling with. Um, it says here a light plane took 1 hour longer to fly 540 miles on the first portion of the trip than to fly 360 miles on the second. If the rate was the same for each portion, what was the flying time for each leg of the trip? All right, so let's just draw a little picture to see what this actually entails. You have the first portion of the trip, which is 540 miles, and the plane's gonna fly this, okay? And then he's gonna fly another trip, which is actually 360 miles, and that is going to take less amount of time. It says here, a light plane took 1 hour longer to fly this portion. Now, we're not told how long it actually took to fly this portion right here. So we're just going to give it a letter T to represent that time. Here, if it says here it took 1 hour longer to fly this portion, then this will be T plus 1 with respect to that over there. Okay. Now, I'm going to also label this as T2 to indicate that this is the second portion of the trip. And this is this time right here, T1, is equal to the second portion of the trip plus an extra hour. Okay. All right, what else do we know? We know that the rate is the same for each portion, meaning the plane is flying at the same speed from the first portion of the trip as well as the second. So the rate at which he flies the first trip is equal to the rate at which he flies the second portion of the trip. Now you might be asking me this question like, what am I supposed to do with all this? And how did you even know, or how does any student understand how to put this all together? Yeah, I don't know. I'm just kidding. Well, you have to know some preliminary things before you even start this problem, which I don't think the teachers are going to go through in class. Let me show you what I mean by that. There is an equation that you have to use whenever you're dealing with rate, time, and distance. It's called RTD. Okay, rate times times equals distance. Rate is the speed at which something travels. Time, and we have distance. Here's an example. If you travel, let's say 60 miles per hour for about 2 hours, how far did you travel? 60 times 2 equals 120 what? 20. And depending on the units that you use, let's just say we're using miles per hour, you've traveled a total of 120 what? Miles. Okay? Now, what you want to do with this equation is learn to rearrange it based on what you need. For instance, this is just a basic algebraic equation where you can actually decide, you know what, let me solve for r by dividing both sides by the letter t. Then you cross out the t's and you realize you have rate equals distance divided by time. And that makes a lot of sense, right? How fast were you driving? Let's say that you've traveled 100 miles, right? And it took you, 20 minutes, right? Then you divide 100 miles by 20 and you'll have the rate at which you traveled. 100 divided by 20 is equal to what? 50. So you've traveled 50 miles per hour. Okay, so what I'm trying to show you is that from one equation, r times t equals d, you can extract two more equations. R is equal to distance divided by time, and also you can also divide both sides by r and set the equation equal to t. T will equal distance divided by rate. So you have three equations to work with. 1, 2, and 3. Okay, let me slow it down here. Okay, this first equation will give you the distance. If you have two values, the rate at which you're traveling and the time, you multiply those two together and you have your distance. If you have distance and you have time, you can divide it and you'll get your rate. And here, if you have your distance and you divide it by your rate, you'll get your what? You'll get your time. So now the question is this. How do you know which one to use? Well, let me get to that in a second. First of all, you can also add one more component to this RTD situation. For instance, let's imagine that you and I were racing, okay? All right, that's you, that's me. All right, and let's say that you're running at a particular distance. I'm gonna label this as 1 and 2. So the distance that you travel, I'm going to call it D1. The distance that I travel, I'll call it D what? D2. You have a particular speed, we'll call that R1, and my rate at which I run will be R2, and let's say you ran for 4 hours, whatever, then it will be T1, and my time will be T what? T2, okay? Now, generally, this is the way it's going to work. For instance, let's imagine that the distance that you ran plus the distance that I ran was a total of 3 miles, right? Then we would write an equation like this. D1 plus D2 equals what? 3, right? The distance that you ran plus the distance that I ran, it totals to 3. So D1 plus D2 equals what? 3. Now, why is this so important? Well, watch this. Whenever you see a letter like this, like D, you go back to your 3 equations and you realize, oh, if I see the letter D, I can replace it with RT. So let me show you what I mean. Distance is always equal to rate times times, right? So you can actually convert this into R1 T1, meaning now we can include your rate and your time and my rate and my time, and it'll still equal 3. All I did was use substitution right here. Let me write this right now. D equals R times T, right? I'm basically using this equation. Whenever I see D, I can replace it with R and what? R and T. And notice what's going to happen. You'll usually be given 3 pieces of information and you're left with just one missing information, and it's just like a variable like X. You fill it all in and you just isolate this variable and you solve your equation. Let me give you another example. Let's imagine that the time it took for you to hike a mountain was, well, we don't know. And the time that it took me to hike a mountain was something. But if we don't know what it is, but if we add it up together, the sum of our time, let's say it equals 7 hour total. Then how do we write our equation? T1 plus T2 equals what? 7. Now you're thinking, well, again, we don't know what the time is. We just know the sum of it. But notice we can change the T into another equation. What is T equal to? T is equal to distance divided by rate. So now I can use D over R and replace T1 with D1 over R1. D2 over R2 equals 7. Now think about what just happened. This equation only had 2 variables and is unknown. But let's just imagine we knew the distance of the hiking trail, and we knew the rate at which we ran. And usually you'll just be given one or the other. We can solve for R, and then once we solve for R, we can go back and plug it into another equation and solve for the letter what? Letter T. There's a lot of stuff you can do. Like this is how they got this equation. Like on the second problem, you read this express train traveling passenger bus, and then they're like, hint, T bus equals T train plus 2. That's exactly what I'm writing. So what is T equal to? T is equal to D over R. So now you can take this hint and say, oh, this is D bus over the rate of the bus equals D, the distance of the train, divided by the rate of the what? The train plus 2. And then you just look at the prompt and look for the information, the distance that the train and the bus traveled, and put the rate at which the bus traveled, and then you solve for the missing information and you're done. You can find each rate, which is basically this letter R here. Because you're asking, like, how did they get this information here? Well, it's all because of the fact that they knew how to put it all together based on these 3 equations, and a simplified time equation like time plus this equals 7, and then they just replaced it. Okay. All right. I know it might be just way over your head right now. Let's do a couple problems and let's see if we can put it all together. All right. So going back here, the goal right now is to find time. What was the flying what? Time. We're solving for T. Okay. For each leg of the trip, the first trip and the second what? Second trip. Again, we don't know the actual time, okay? But we do know that time 1, the first leg of the trip, it took 1 hour more than whatever amount of time it took to travel for time what? Time 2. Now notice what we can do. I'm going to take this equation right here, and I'm going to say, okay, I don't know the time for each, but I know some other information. So I'm going to convert this equation with d over r. Okay, again, what is t equal to? Let me just rewrite it for you. So we have r times t equals d. You divide both sides by r, like this, and now you have t equals d over r. So I'm going to take this t, each of those t, and rewrite it as d over r with a subscript to represent we're dealing with that particular time. So this will be d1 over r1. This will be d2 over r2 plus 1. So I'm going to go like this. Empty parenthesis for each of those. Oops, there should be an equal sign. Okay. All right, so here's a question. Do we know the distance of the first part of the trip, d1? Yes, it's basically 500 and what? 40. So we can go up here and just rewrite this as d1 equals 540, d2 equals 360. So we just plug it in. So 540 here, 360 there. Now, what about our R's, our rates? Well, we're told that R1 equals R2. We don't know how fast they are going, but they're going at the same what? Same speed. Or the first trip speed and the second speed trip is exactly the same. So what do? Well, we just turn it into one variable then. Since R1 and R2 are essentially the same, let's just turn it into one or the other variable. Let's just call it, we'll just leave this as R1 and let R2 also equal R what? R1. Does that make sense? Because they're exactly the same. And what we ultimately want is one equation with one variable. If you have two sets of variables, you can't solve it unless you have two equations. If you have three unknowns, you need three equations. That's the way it works. Okay? All right, so we have now one equation with one set of variables that's exactly the same, and all we have to do now is apply some algebra, and we are what? Done. All right, so what do? Now we can get common denominator, but let's just multiply both sides of the equation by whatever that common denominator might be. It happens to be R1, so let's multiply both sides by R1. R1. If I multiply this side for R1, R1s will cancel out. And what do we have left? We have 540 equals. Here, we're going to distribute R1 to here, and notice these two will cancel out, right? I'm just going to put that slash there. We'll have 360 left, so 360. Lastly, R1 times R1 times 1 is just R1. Look how simple our equation has become. We solve for R1 by subtracting 360 to both sides. And voila, what do we have? So 0 minus 0, 0, 14 minus 4 minus 6, what's that? Put 10 minus 4, 4, 8. Okay, sorry, I'm just doing this in my head. 4 minus 3 is 1. The rate of the first train is 180 miles. That's kind of fast, huh? What is this going? 540 miles per hour. Okay, I must have done something wrong because it shouldn't be that crazy fast. No, actually, no, it's right because it's a plane flying. So I thought it was like a train. Sorry, I was like, no train goes 180 miles per hour. Okay, on the first, so R1 equals R2. So basically, all right, the rate at which he travels the first is the rate at which he travels the second. But what are we looking for here? We're looking for what was the flying time. Okay, we want to know the exact time, right? So how do we find time? Look right here. Time is the distance divided by rate. We know our rate, which is 180. The first part of the trip was 540, so time 1 is 540 divided by 180, and we get 540 divided by 180 is 3. So it took 3 hours on the first leg of the trip. Well, it's plus 1. And then T2 is equal to 360 divided by 180. 360 divided by 180, and that should equal 2, right? 360 divided by, 180 times 2 is 360, duh. All right, so this makes a lot of sense. The first part of the trip took 1 hour longer than the second part of the what? The trip, okay? So leg 1, if you want to put it that way, took 3 hours. Leg 2 took 2 what? 2 hours, and we are done. All right. Yes. I know when I zoom out, it looks really complicated, but it was easy, right? Okay, just rewind this whole thing and look at it again. All right, let's try this next one. An express train and a passenger train leaves the same city at the same time. And by the way, when I read the phrase at the same time, I'm going to go T and let's see, got express. So I'll put TE to represent express train and TB for bus. So we're going to set that equal to each other. Okay. They left at, oh wait, actually, no, let me take that back. They just left at the same time. We don't know how far, how fast and how far they were going. So let's see, an express train and a passenger bus leave the same city at the same time for a destination 350 miles away. All right, so let's say that they start here and they went here and it's 350 miles away. The rate of the train, there it is 20 miles per hour faster than the rate of the bus. Okay, so the rate of the train, how does it compare to the rate of the bus? Well, if the rate of the bus is faster, 20 miles per hour faster, then if I add it to rate of the bus, they should technically be exactly the same. Does that make sense? Kind of look at this. They should start making sense. Okay, the rate of the train is faster, so 20 miles per hour faster. So if the bus can go 20 miles per hour faster than what it's normally used to, it will be equal to the what? It will be equal to the rate of the train. So we have that. Next, if the train arrives at its destination 2 hours ahead of the bus, find the rate of each train. Okay, let's turn this into an equation. Time. So the train obviously arrives faster, 2 hours faster, so less time, right? So the time of the train in comparison to the time of the bus, how do we turn it equal to each other? Right now they're not equal. We have to put the 2 hours somewhere. Where would we put 2 hours? Well, again, since the train is faster, it used less time. So if I add 2 to the time of the train, it should equal the time of the what? Time of the bus. Okay, does that make sense? Kind of have to pause this and think about that for a second. The bus took longer to get there, 2 hours longer. The train took 2 hours shorter. So if I give 2 hours to the train, their time should be exactly what? The same. Now you notice we already have two equations that we can actually work with. And notice this equation is basically the equation right over what? Here, do you see this? T bus is equal to T train plus an extra 2 what? 2 hours. That's how they got this. Okay. All right, so what are we looking for? We're looking for rate. Now, since we're looking for rate, we're not going to use this equation. We're going to use this equation. Okay, because here we can't really plug in anything for R, but here we can actually plug in something for T, or you'll see what I mean in a second, and we'll eventually get something with an R in there. Okay, so what is T equal to again? So let's review our equations. D is equal to RT. If you divide both sides by R, this will be D over R is equal to T, and D over T is equal to R. Which one are we going to use? I'm going to use this one. So I'm going to replace the T's with D over R. So I'll replace T of the time of the train. I'll write distance of train divided by the rate of the train plus 2 equals the distance of the bus divided by the rate of the bus. Okay. All right. So we're going to work with this, and notice if we can solve this equation with R in it, or we solve for R, we have our answer. Do we know the distance of the train? Yes. Both of them are going to be exactly the same. They've traveled from the city to their destination. Both of them traveled 350 miles. So I'm going to replace dt and dB with 350. Okay. Okay. All right. Now, again, as I told you, you have one equation, but now we have two different variables. I mean, even though both of them have the letter R, this R represents a different, it represents the train, and this one represents the bus. So there are two different variables here. how do we turn this equation into just one type of a variable? Well, guess what? We know this. RT is equal to RB plus 20. So let's take all of that and substitute it right over here. And then you'll notice everything's going to turn into an RB equation. So 350 divided by RB plus 20. Again, all I'm doing is substituting RT for this because in the beginning I said, or we stated that RT is equal to that right there. And this is equal to, oh, I'm sorry, plus 2 is equal to 350 over R what? RB. Okay? So now we have one equation with one type of variable. Just do your math and we're done. I mean, you can call this, you know, X, right? If RB is too hard, it's just a variable. It's the same thing. Okie dokie. So what's our common denominator? Well, it'll basically be like RB times RB plus 20. You have to kind of combine those two. So on the left side, here, I'll do it on the line right before this so that you'll know what happened. So let's see, 350 over RB plus 20 plus 2 equals 350 over RB. And I'm going to take the left side and put a bracket on the whole thing. And then the right side, put the bracket on the whole thing. And I'm going to multiply both sides by the common denominator, which is RB times RB plus 20. Okay, this is, you know, the same thing as doing the rational expressions, rational equations. And on the right side, again, RB times RB plus what? 20. All right. So again, if you didn't realize that this is basically a fraction, okay? All of that over 1. If you multiply this to this, RB plus 20 cancels out, and you're left with RB, and so you multiply that to 350, so you'll get 350 RB. Plus, you're going to multiply this to number 2, you're going to distribute all of that, and you have to write the whole thing out. There's nothing to cancel, so this will be 2 RB times RB plus what? 20. And on the right side, you'll notice that you can cancel the RBs out and you'll have equals 350 parenthesis RB plus what? RB plus 20. Okay? All right, notice this. We have, I know it looks kind of ugly, but it's fine because we have one equation. Everything is RB now. So all we have to do is combine like terms and solve, and we're going to be done. So let's work this out here. So we got 350 RB. Okay. Here we need to distribute the 2RB to RB plus 20. So that's going to become 2RB squared plus 2RB. Oh, so I'm sorry, 40RB. Now, if the whole like RB squared looks kind of complicated, let's switch to an easy like variable to work with. Okay. So let me just finish writing this out. So this is 350 RB plus, now what's 350 times 20? Well, 35 times 20 is 7, so maybe 7,000. 350 times 20 is 7,000. Okay. All right, so here, let me just change the letter RB into just R, okay? So 350 R plus 2R squared plus 40R equals 350R plus 7,000. This is a quadratic equation, so we're going to set it equal to 0 and solve. But can we, you know, combine some like terms first? That like this right here will become 390R. So this is 2R squared plus 390R equals 350R plus 7,000. And anytime you have something with a squared, it's a quadratic function or quadratic expression or equation, and you always have to set it equal to 0. You either try to factor it or use the quadratic formula. So 2R squared plus 390R minus 350R minus 7,000 equals 0. So let's simplify this out. So this will be 2R squared plus 390 minus 350, which will be, what is that, 40? Yep, 40R minus 7,000 equals 0. All right. we factor this out. Now this is where everyone's like, oh, can we just finish this? Yes. Now, if you just don't want to factor it, just plug it into the quadratic formula and you're done, especially if you have a calculator, okay? So let me just do the simplifying aspects in case some of you actually want to do that. So this is 2 divided by 2, divided by 2, divided by 2. And again, I only do this when it's equal to 0. This would be r, oops. This would be r squared plus 20r minus 7,000 divided by 2 is 3,500 equals 0. All right, that doesn't really help us out there, huh? This number is really, really big. Okay, I'm just gonna plug into the quadratic formula. So this would be like negative 20 plus or minus square root of 20 squared minus 4 times 1 times negative 3,500 all over 2 times 1. Okay, if you don't know this, you need to memorize this. This is the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. This is the go-to formula for any quadratic equation that you can't factor out simply. Now, I know the numbers look pretty big, but calculator will do all the work for you, okay? All right? Okay, so 20 squared minus, and then here it will be negative and negative will be positive. So this would be plus 3,500 times 4 equals. So we got the square root of 14,400. Ah, that looks like something with the 12, because the square root of 144 is 12. Okie dokie. So let's take the square root of our answer, and we get negative 20 plus or minus 120 over 2. Awesome, right? We have a negative 20 plus 120 over 2 versus negative 20 minus 120 over 2. Now, I'm going to immediately cancel this out because you're going to get a negative number. We're not going to get a negative rate. So you can just disregard that. Here, 120 minus 20, that's 100. 100 divided by 2 is 50. So R is equal to 50. But remember, we have an R for a particular item. It's the bus. Where did it go? Where did it go? Yes. RB is what we started off with before we simplified it into just an R. So the rate of the bus is 50 miles per hour. Oh my goodness, that's so long. Okay. And the rate of the train is what? The rate of the train is 20 miles per hour faster. So if you just add 20 more, we'll get the rate of the train. So our train equals 70. There it is. Okay. Now, if my answer is wrong, let me know in the comments below, and I'll I'll correct my work. But so far, so good. Okay, have a good night. I'll see you later.